Hello, in this lecture we will find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AD equals to 3 units, side AB equals to 5 units, side CD equals to 6 units, and angle ADC, this angle equals to 90 degrees. Angle ABC equals to angle DCB equals to theta. And we want to find out the length of line segment BC that is equal to X. So let's start with the first method. In the first method, we'll do a construction. We'll extend side AB and side CD until they intersect with each other. And we'll define the intersection point between the extended side AB and the extended side CD as E. So here we created triangle EBC. In triangle EBC we have two equal angles. Those two angles are equal to each other. They are both equal to theta. So in the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So I'll write it down. So I will read rule number 1 again. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So here we will relate to triangle EBC. In triangle EBC, we have two equal angles. According to what is given us in the question, angle EBC, this angle, is equal to this angle that is actually angle ECB. And both angles are equal to theta according to what is given us in the question. So from the fact that those two angles are equal to each other, we will conclude that according to equation number 1, side EB must be equal to side EC. EB equals to EC. Okay, this is equation number 1. So EB equals to EC. EB equals to 5 plus AE. and EC equals to 6 plus ED. So in conclusion, we found out that 5 plus AE equals to 6 plus ED according to equation number 1. We will subtract 5 from this equation, equation number 1, and we will get that according to equation number 1, AE equals to 1 plus ED. Here we will define ED as A. ED equals to A. So here we can write down that ED equals to A. So we'll substitute ED by A in equation number 1, and we'll get that according to equation number 1, AE equals to 1 plus ED, and ED is A. So in conclusion, we found out that AE equals to 1 plus A. So here we can write down that AE equals to 1 plus A. So here, before we did the construction, we had a quadrilateral ABCD. In quadrilateral ABCD, side CD is one side of a quadrilateral ABCD. I will repeat again. Side CD is one side of quadrilateral ABCD, and therefore it is absolutely a straight line. Okay, so side CD is a straight line. Then when we extended the straight line CD by a straight line, we got line segment CE or side CE. And when you extend a straight line by a straight line, the result must be a straight line. Therefore, the result CE is a straight line. So in conclusion, we found out that CE is a straight line. So we can write down here that CE is a straight line. And we have also rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So I'll write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. So I'll read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, if we focus on this side of the straight line EC at point D, then the sum of the angles on this side of the straight line EC at point D must be equal to 180 degrees according to rule number 2. So which angles we have at this side of the certain isolated point D. We have here 90 degrees. And we have also this angle, this is actually angle ADE. So the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. 90 degrees plus angle ADE in total must be equal to 180 degrees according to rule number 2. Here we subtract 90 degrees from this equation and we get that the missing angle ADE is equal to 180 degrees minus 90 degrees, it is 90 degrees. So this angle ADE is a right angle. So if angle ADE is a right angle, it means that triangle ADE is a right triangle. The green triangle ADE is a right triangle. So we can implement the Pythagoras theorem on the green right triangle, triangle EDA. Here by PT is the progression by Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So that is to say, the square of the hypotenuse is AE square and it is equal to AD square plus ED square. Okay. So AE square equals to AD square plus ED square. Here AE equals to 1 plus A, so we substitute AE by 1 plus A. If A equals to 1 plus A, it means that A square equals to 1 plus A square. And it is equal to AD square. AD equals to 3, so AD square equals to 3 square, that is 9. Plus ED square. ED equals to A, so ED square equals to A square. So in conclusion, according to equation number 2, we found out that 1 plus A square equals to 9 plus A square. Here we will open the brackets on this side of equation number 2 and we get that according to equation number 2, one plus A square equals to 1 plus A square plus 2A, and it is equal to 9 plus A square. Here we have A square on both sides of equation number 2, so A square will get cancelled. And we left only with one plus 2A equals to 9. Here we will subtract 1 from this equation, equation number 2, And we get that according to equation number 2, 2a equals to 9 minus 1, that is 8. So 2a equals to 8, we divide this equation by 2, equation number 2 by 2, and we get that a equals to 8 over 2 is 4. So we found out that a equals to 4. A equals to 4. Therefore, a plus 1 will be equal to 5. In the next step, we will define angle AED as alpha. We will focus on the right plane triangle, triangle AED. Actually, in the right plane triangle, triangle AED, we know that cosine alpha equals to ED over EA. Here ED equals to 4 and A equals to 5, so here ED equals to 4, EA equals to 5, so in conclusion we found out that cosine alpha equals to 4 over 5. In the next step I present to you a new law that is the law of cosines, and we will implement the law of cosines in this triangle, triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. And we know that side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is alpha. Then, according to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. Okay. And we can use this equation in any triangle. Again, C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. This is the law of cosines, and we will implement the law of cosines in our triangle ABC. So in this triangle ABC, EB equals to A, EC equals to B, BC equals to C, that is also equals to X, of course. EB, the length of EB is 5 plus 5, that is 10. So EB equals to 10 units. And EC equals to 4 plus 6, that is also 10. And cosine alpha equals to 4 over 5, according to what we have already found out. So we will implement the law of cosines in this triangle ABC. So here, according to the law of cosines, we get that C squared is BC squared, this will be equation number 3. So here BC squared equals to A squared, that is EB squared, plus B squared, that is actually EC squared, minus 2 times EB is 10 and EC is also 10, times cosine alpha, but cosine alpha equals to 4 over 5. So we substitute cosine alpha by 4 over 5. So in conclusion, so in triangle ABC, of course, this is the implementation of the law of cosines in triangle ABC. BC equals to x, so BC squared will be equal to x squared. So we substitute BC squared by x squared. And it is equal to EB squared. EB equals to 10, so EB squared is 10 squared, that is 100. Plus EC squared. EC also equals to 10, so here EC equals to 10, so EC squared is 10 squared, that is also 100, minus 2 times 10 times 10 is 100. Times 4 over 5. So according to equation number 3, we got that x squared equals to 100 plus 100 is 200, and 200 minus 2 times 100 is minus 200 times 4 over 5. So according to equation number 3, I found out that x squared equals to 200 minus 200 over 5 is minus 40, and minus 40 times 4 is minus 160. So according to question number 3, x squared equals to 200 minus 160 is 40. X squared equals to 40, so we'll take out of this equation number 3, and we will find out that x equals to the square root of 40. 40 is 4 times 10, so we substitute 40 by 4 times 10. And the square root of 4 is 2 times square root of 10. So x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. I repeat again. In side BC that is equal to x, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we finished with the first method. In the next step, I will present to you how to find out the length of line segment BC that is equal to x according to the second method. In the second method, we will do another construction. From point A, we draw straight line on DC in such a way that the straight line will be parallel to BC. Okay, so here we define the touching point of the straight line from point A and DC is F. I'll repeat again that we draw the straight line AF in such a way that AF will be parallel to BC. So I can write here that AB is parallel to BC according to our construction. Likewise, from point, actually We define the touching point of the straight line from point A and DC is E. Then from point E, we draw, likewise from point E, we draw a straight line on BC in such a way that the straight line will be parallel to AB. Okay, so here and we define the touching point of the straight line from point E and BC as F. I repeat again that we draw the straight line EF in such a way that it will be parallel to AB. So can I tell here that EF is parallel to AB according to our construction. Here, in the first step, AE is parallel to BC according to our construction. Here it is AE that is parallel to BC, and in the second construction, EF is parallel to AB according to our construction. I will repeat again that in the first construction, AE is parallel to BC according to our construction, and in the second construction, EF is parallel to AB according to our construction. So here actually we created quadrilateral AEBF and quadrilateral AEBF as two couple of sides that are parallel to each other. AE is parallel to BF and AB is also parallel to EF. Therefore, quadrilateral ABEF is a parallelogram. So can I write down that quadrilateral ABEF is a parallelogram. Okay. In the next step, I'll present to you a new rule that is actually rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So I write it down. corresponding angles between parallel lines are equal to each other. I'll repeat on rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here, according to our construction, AB is parallel to EF. So here, those two angles that are defined as corresponding angles that are located between the parallel lines AB and EF will be equal to each other. So angle ABC, this angle, is equal to this angle that is actually angle EFC. Angle ABC equals to angle EFC according to rule number 3. Those two angles are defined as corresponding angles and are located between the parallel lines AB and EF, therefore are equal to each other according to rule number 3. But angle ABC equals to theta according to what is given us in the question. So we can write here that angle ABC equals to theta, and from this equation theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. Here angle EFC is also equals to theta. And according to our construction, AE is parallel to BC. So we can write here that AE is parallel to BC according to our construction. Therefore, according to rule number 3, those two angles that are defined as corresponding angles and are located between the parallel lines A and BC will be equal to each other. So this angle is actually angle AD. Will be equal to this angle, that is actually angle DCB. According to rule number 3, of course, so according to rule number 3, angle AED equals to angle DCB but angle DCB equals to theta. According to what is given us in the equation, angle DCB equals to theta. So from this equation, angle AD equals to angle DCB equals to theta, we will derive that angle AED is also equals to theta. So this angle AED, is also equals to theta. In the next step, I will present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. We'll write it down. So I will read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So if we relate to our parallelogram AEBF, P is the abbreviation for parallelogram. So in our parallelogram, according to rule number 4, AB equals to EF. AB equals to EF. According to rule number 4, of course. But according to what is given on the question, AB equals to 5 units. Here we can write down that AB equals to 5 units. And from this equation, 5 equals to AB equals to EF. We will derive that EF is also equals to 5 units. EF is also equals to 5 units. So we have triangle EFC. We will focus on triangle EFC. In triangle EFC, we have two angles that are equal to each other. Those two angles that are equal to each other, they are both equal to theta. So angle EFC is equal to this angle that is actually ECF, and they are both equal to theta. Therefore, according to rule number 1, we will derive from it that EF is equal to EC. EF is equal to EC according to rule number 1. Rule number 1 states that in front of equal angles in the triangle there are equal sides. Therefore EF equals to EC according to rule number 1. But EF equals to 5 units. We just right now found out that EF equals to 5 units. So from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. Here EC equals to 5 units. And what is the length of side the small line segment DE? From the drawing it is very easy to see that DE equals to DC minus EC. Again, DC minus EC equals to DE. So I write it down. I repeat again, from the drawing it is very easy to see that DE equals to DC minus EC. So DE equals to DC, here DC equals to 6 units according to what is given us in the question, and we already found out that EC equals to 5 units. So in conclusion, we found out that D equals to 6 minus 5, that is 1. So DE equals to 1 unit. DE equals to 1 unit. We will focus on the right triangle ADE. We'll implement the Pythagoras theorem on the right triangle ADE in order to find out the hypotenuse AE. Okay. So in the right green triangle ADE, my PT is Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AE square, and it is equal to AD square plus DE square. So here, according to question number 1, AE squared equals to AD squared plus DE squared. So AE squared equals to AD squared. AD equals to 3 according to what is given us in the question. So AD squared is 3 squared, it is 9, plus DE squared. DE equals to 1 according to what we have already found out. So DE squared will be equal to 1 squared, that is 1. So in conclusion, we found out that AE squared equals to 9 plus 1, that is 10. So according to equation number 1, AE squared equals to 10. We take out of this equation number 1, and we get that AE equals to the square root of 10 units. So you can write here that AE equals to the square root of 10 units. Now we can implement rule number 4 in the parallelogram AEBF. The opposite sides of a parallelogram are equal to each other, that is to say AE equals to BF according to rule number 4. So here, in parallelogram AEBF, according to rule number 4, AE equals to BF. That the opposite sides of a parallelogram are equal to each other. But we just right now found out that AE equals to square root of 10 units. So we can write here that AE equals to the square root of 10 units. And from this equation, square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to square root of 10 units. So we found out that BF equals to the square root of 10 units. Now we find out the length of side FC or line segment FC. It is very easy to see from the drawing that the length of side FC it is actually equals to BC minus BF. Again, BC minus BF equals to FC. So FC equals to BC is X according to what is given us the question. And BF, we just right now found out that BF equals to the square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. So we can write here that FC equals to X minus square root of 10 units. Okay. In the next step, we'll focus on triangle EFC. This triangle EFC. Triangle EFC is an isosceles triangle because of the fact that side FE equals to side EC equals to 5 units. Okay. And the base of triangle EFC is FC. Okay, FC is the base of triangle EFC, the isosceles triangle EFC. FC is the base. In the next step, from point E, we draw perpendicular on FC, on the base FC. And we will define the touching point of the perpendicular from point E and FC as L. So here, this angle equals to 90 degrees and this angle will also equal to 90 degrees according to our construction. So EM is perpendicular to FC, EM is perpendicular to the base FC. And whenever a line segment that exists from the vertex is perpendicular to any side of a triangle, it is defined as a height. So EM is the height to the base FC. So we write it down that EM is the height to the base FC. Okay, so in the next step I will present to you a new rule, that is rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So I write it down. The height to the base in an isosceles triangle so the right to the base in an isosceles triangle bisect the base. And read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisect the base. So we will relate to our isosceles triangle ABC, and we implement rule number 5 in this triangle, in this isosceles triangle EFC. So according to rule number 5, the height EM to the base FC bisect the base. So according to rule number 5, the height EM bisect the base FC, that is to say, it divides it into two equal parts. That is to say, FM equals to MC. In triangle EFC, according to rule number 5, FM equals to FC. So FM equals to FC according to rule number 5. Because of the fact that the height EM bisects the base FC, it means that it divides the base FC into two equal parts. That is to say, FM equals to MC. According to rule number 5, FM equals to FC. FM equals to MC actually. FM equals to MC. FM equals to MC according to rule number 5. And according to rule number 5, the ITM bisects the base FC. That is to say, it divides it into equal parts. So if the first part is FC over 2, then the second part will be also FC over 2. That is to say, FM equals to FC over 2 and MC also equals to FC over 2. So here FM equals to FC over 2 and MC equals to FC over 2, so we can write here that FC over 2 equals to FM and it is also equals to MC. Okay? So we know that MC equals to FC over 2. That is to say, it is equal to FC, that is x minus square root of 10 over 2. In conclusion, I found out that MC equals to x minus square root of 10 over 2. Okay, so we can write here that MC equals to x minus square root of 10 over 2. in the next step, we will prove that those two right triangles are similar to each other. We will prove that the right big triangle, the right big green triangle, triangle EMC, is similar to the right small triangle, right small green triangle, triangle ADE. So why those two green right triangles are similar to each other? First of all, we'll focus on triangle EMC, the right triangle EMC. We know that this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles 280 degrees in the right green triangle EMC. This angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Therefore, in order to complete the sum of the angles in the right triangle EMC to 280 degrees, this angle must be equal to 90 degrees minus theta. For the same reason, exactly for the same reason, in triangle ADE, this angle must be also equal to 90 degrees minus theta. So actually, those two angles are equal to each other, and they are both equal to 90 degrees. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle EAD with triangle ADE and triangle EMC. So because of the fact that angle EAD, this angle is equal to this angle, that is actually angle MEC. And both angles are equal to 90 degrees minus theta. I'll repeat again. Angle EAD equals to angle MEC equals to 90 degrees minus theta. In addition, those two angles, they are both equal to theta, therefore they are equal to each other. So angle AED equals to this angle, this is actually angle ECM, and they are both equal to theta. Finally, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle ADE equals to angle EMC, and they are both equal to 90 degrees. So I actually proved that all the angles of triangle ADE equals to the angles of triangle EMC, therefore those two triangles are similar to each other according to angle similarity rule. So I'll write it down. Triangle ADE is similar, this is the sign of similar, to triangle EMC according Here triangle AD is similar to triangle EMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive hence that AE over EC equals to DE over MC. I'll repeat again. From the fact that triangle AD is similar to triangle EMC, we derive that AE over EC equals to DE over MC. AE over EC equals to DE over MC. AE equals to square root of 10 units, EC equals to 5, DE equals to 1, and MC equals to x minus square root of 10 over 2. In conclusion, we found out that square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we will move 2 to the numerator and x minus square root of 10 to the denominator of this side of equation number 2, and we get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we will cross multiply this equation number 2, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 5 times 10, that is 10. Here we'll substitute 10 by square root of 10 times square root of 10, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. Here we divide this equation number 2 by square root of 10, and we get that according to equation number 2, square root of 10 over square root of 10 is 1, so here we left only with x minus square root of 10, and there square root of 10 times square root of 10 over square root of 10 is square root of 10. So here we will add square root of 10 to this equation number 2, and we get that x equals to square root of 10 plus square root of 10 is 2 times square root of 10. So x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the second method. In the next step, I'll summarize the lecture. We start with the first method. So I repeat on the question, we have here quadrilateral ABCD, side AB equals to 5 units, side AD equals to 3 units, side AC equals to 6 units, angle ADCD angle equals to 90 degrees, angle ABC equals to theta, and then angle DCB is also equals to theta, and we want to find out the length of side BC that is actually equals to x. So in the first method we did the construction, we extended side BA and side CD by a straight line until they intersect with each other at point E. And actually we created here triangle EBC. In triangle EBC we have two angles that are equal to each other, they are both equal to theta. Okay. And then I presented to you rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So here we will relate to triangle ABC. In triangle ABC, we have those two angles that are equal to each other, they are both equal to theta. So here, angle ABC equals to angle ECB equals to theta, according to what is given as the question. Therefore, according to rule number 1, front of those two equal angles, there are equal sides, that is to say EB equals to EC. Again, EB equals to EC according to rule number 1. Again, EB equals to EC according to rule number 1. EB equals to 5 plus AE. Here, EB equals to 5 plus AE, and EC equals to 6 plus ED. EC equals to 6 plus ED. We subtracted 5 from this equation, equation number 1, and found out that AE equals to 1 plus ED. Then we defined ED as A. Here ED equals to A according to our definition. So we substituted ED by A in equation number 1. So according to equation number 1, A equals to 1 plus ED, and ED is A according to our definition. So we substituted ED by A, and we got that according to equation number 1, A equals to 1 plus A. Here AE equals to 1 plus A. So before we did the construction here, we had quadrilateral ABCD. CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line. And then when we extended the straight line CD by a straight line, the result is also must be a straight line. So the result that is CE, it must be a straight line. Because when you extend a straight line or a straight line, the result must be a straight line. So the result that is CE, it must be a straight line. So can I know that CE is a straight line? Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees, according to rule number 2. So which angles we have at point D? We have 90 degrees plus angle ADE. I told that the sum of the two angles must be equal to 180 degrees. Here 90 degrees plus angle ADE must be equal to 180 degrees, according to rule number 2. We subtracted 90 degrees from this equation, and found out that the missing angle ADE equals to 90 degrees. Here this angle equals to 90 degrees. Angle ADE equals to 90 degrees, therefore the green triangle AD is a right triangle. So we can implement the Pythagoras theorem on this green right triangle. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AE square equals to AD square plus AD square. in the right triangle ADE, according to the Pythagoras theorem, AE squared equals to AD squared plus ED squared. AE equals to 1 plus A, so A squared is 1 plus A squared. AD equals to 3, so AD squared is 3 squared, that is 9. ED equals to A, so ED squared is A squared. So in conclusion, found out that according to equation number 2, 1 plus A squared equals to 9 plus A squared. Here we open the brackets on this side of equation number 2 and found out that 1 plus A squared equals to 1 plus A squared plus 2A, and it is equal to 9 plus A squared. Here we have A squared on both sides of equation number 2, so A squared will get cancelled, and we left only with 1 plus 2A, that is equal to 9. We subtracted 1 from this equation, equation number 2, and we got that 2A equals to 9 minus 1, that is 8. So 2A equals to 8, according to equation number 2, we divided this equation, equation number 2 by 2, and we found out that A equals to 8 over 2, that is 4. So we found out that A equals to 4, therefore A plus 1 is 5. Then we define the angle BEC, this angle is alpha. Here cosine alpha equals to ED over AE. Okay, cosine alpha in the right triangle ADE equals to ED over AE. ED equals to 4, AE equals to 5. So in conclusion, found out that cosine alpha in the right small green triangle EDA equals to 4 over 5. Then I presented to you the law of cosines, and we implemented the law of cosines in the now triangle ABC. So the law of cosines is true in any triangle, so if you have this triangle ABC, that could be any triangle, and we know that side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. Then according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. Okay, we can use this equation in any triangle. So implemented the law of cosines in our triangle ABC. Now a triangle ABC. A equals to EB, EB equals to A, EC equals to B, and BC equals to C. That is actually also equals to X. So EB equals to 5 plus 5, that is 10, and EC equals to 4 plus 6, that is also 10. And cosine alpha equals to 4 over 5. So according to the law of cosines, we will get that in our triangle ABC, that BC squared equals to EB squared plus DE squared minus 2 times EB times EC times cosine alpha. Cosine alpha equals to 4 over 5. So we substitute cosine alpha by 4 over 5. EB equals to 10, EC equals to 10, so we substitute EB and EC by 10. BC equals to X, so BC squared is X squared. EB equals to 10, so EB squared is 10 squared, that is 100. ED is 10, so ED squared, it is 10 squared, that is also 100. Minus 2 times 10 times 10 is minus 200 times 4 over 5. So in conclusion, we found out that according to equation number 3, X squared equals to 100 plus 100 is 200, minus 2 times 100 is minus 200 times 4 over 5. So we got that according to equation number 2, X squared equals to 200 minus 200 times 4 over 5. Here 200 over 5 is 40, and 40 times minus 40 times 4 is minus 160. So in conclusion, found out that according to equation number 3, x squared equals to 200 minus 160. 200 minus 160 is 40. So we found out that according to equation number 3, x squared equals to 40. We took out of this equation, equation number 3, and we found out that x equals to the square root of 40. 40 is 4 times 10, so we substituted we substituted 40 by 4 times 10, and the square root of 4 is 2, so in conclusion we found out that x equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. So we finished with the first method. In the next step I will present to you how we found out the length of side BC that is actually equals to x according to the second method. In the second method we did another construction. Here from point A we draw a straight line on DC in such a way that AE is parallel to BC. Then from point E we draw a straight line on BC in such a way that EF is parallel to AB. So in conclusion, AE is parallel to BC and EF is parallel to AB according to our construction. So we created here quadrilateral AEBC that is a parallelogram. Any quadrilateral that has two couples of sides that are parallel to each other is defined as a parallelogram, and here the quadrilateral AEBF, AE is parallel to BF, and the second couple of sides that are parallel to each other is AB is also parallel to EF. Therefore, this is exactly the definition of a parallelogram. So, quadrilateral AEBF is a parallelogram. Okay? Then I presented to you rule number 1. According to rule number 1, presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here, according to our construction, AB is parallel to EF. Therefore, those two angles that are defined as corresponding angles and are located between the parallel lines AB and EF will be equal to each other. According to rule number 3, so I would say. So here, because of the fact that AB is parallel to EF, therefore according to rule number 3, angle ABC will be equal to angle EFC, because those two angles are defined as corresponding angles, and they must be equal to each other according to rule number 3. But it is given us in the question that angle ABC, this angle equal to theta, so we can write here that angle ABC equals to theta, and from this equation theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. This angle EFC is also equals to theta. Okay? Likewise, according to our construction, AE is parallel to BC. Therefore, those two angles that are defined as corresponding angles will be equal to each other because of the fact that they are located between the parallel lines AE and BC. Therefore, they will be equal to each other according to rule number 3. I repeat again, angle, because of the fact that according to our construction AE is parallel to BC, we will derive from it that according to rule number 3, angle AED equals to angle BCD. Okay, angle AED equals to angle BCD according to rule number 3. But this angle BCD equals to theta, this angle that is actually angle, this angle DCB equals to theta according to what is given as the question. This angle BCD equals to theta according to what is given as the question. So here we have the equation that theta equals to BCD equals to AED. From this equation, we will derive that angle AED is also equals to theta. So here angle AED is also equals to theta. This angle AED equals to theta. Okay? In the next step, I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So if we focus on parallelogram AEBF, according to rule number 4, its opposite sides must be equal to each other. That is to say, AE must be equal to BF. Okay, in parallelogram AEBF, according to rule number 4, AE must be equal to EF. But AB equals to 5 units according to what is given as the question. So from this equation, 5 equals to AB equals to EF, we derive that EF is also equals to 5 units. EF equals to 5 units. Okay? Here, we will focus on triangle EFC. Triangle EFC, we have two angles that are equal to each other, they are both equal to theta. So in triangle EFC, we have angle FEC that is equal to angle ECF, and they are both equal to theta. Okay? Therefore, according to rule number 1, in front of equal angles in the triangle, there are equal sides. That is to say, EF must be equal to EC. EF must be equal to EC according to rule number 1, but EF equals to 5 units. We just right now found out that EF equals to 5 units. EF equals to 5 units, and from this equation, that 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. If EC is also equals to 5 units, then we found out the length of the short line segment DE. What is the length of line segment DE? DE equals to DC minus EC. Again, DE equals to DC minus EC. DC equals to 6 units, EC equals to 5, so in conclusion found out that D equals to 6 minus 5, that is 1. So if DE equals to 1 unit, now we can implement the Pythagoras theorem on the small green right triangle, triangle ED. The only missing side is the hypotenuse AE. According to the Pythagoras theorem, in the right triangle AED, or ADE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is AE squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD squared plus DE squared. So AE squared equals to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So in conclusion, we found out that AE squared equals to 9 plus 1, that is 10. So according to equation number 1, AE squared equals to 10. We took out of this equation number 1, and we found out that A equals to the square root of 10 units. So we can write here that A equals to the square root of 10 units. Now we can implement rule number 4 in parallelogram AEBF. According to rule number 4, AE equals to BF. The opposite sides of a parallelogram are equal to each other, that is to say, AE equals to BF. But we have already found out that A equals to the square root of 10 units. So from this equation, square root of 10 units equals to AE equals to EF, we will derive equals to BF, we will derive that BF equals to the square root of 10 units. So here, BF equals to the square root of 10 units. So if BF equals to the square root of 10 units and BC equals to X, then we will get that FC equals to BC minus BF. Okay, FC equals to BC minus BF. BC equals to X according to what is given as the question. We just right now found out that BF equals to square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. So we can write here that the side FC equals to X minus square root of 10 units. In the next step, we focused on triangle FEC. This triangle FEC, It is an isosceles triangle. Why? Because FE equals to EC equals to 5 units. I'll repeat again. Triangle FEC is an isosceles triangle because of the fact that side FC equals to side FE equals to 5 units. Okay, and the base of the isosceles triangle, triangle FEC, is FC. Again, FC is the base of the isosceles triangle, triangle EFC. So, in the next step, from the vertex E, we drew perpendicular on the base FC. So this angle equals 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point E and FC as M. So we know that EM is perpendicular to FC. Therefore, this is exactly the definition of the height. That is to say, EM, that is perpendicular to FC, is the height to the base FC. Again, EM that is perpendicular to the base FC is the height. So EM is the height to the base FC of the isosceles triangle, triangle EFC. Then I presented to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So here, according to rule number 5, the height EM to the base FC bisects the base FC. That is to say, according to rule number 5, first of all, FM equals to MC. FM equals to MC according to rule number 5. And because of the fact that what is the meaning of the sentence is bisects the base. It means that it divides the base FC into two equal parts. So, if this part is FC over 2, this part must be also equal to FC over 2. So, each part is FC over 2. Okay? The meaning of the rule number 5 that it bisects the base, it means that it divides it into two equal parts. That is to say, if Fm equals to Fc over 2, then Mc must be also equal to Mc over 2. So in conclusion, we found out that Fc over 2 equals to Fm equals to Mc according to rule number 5. Okay, so from rule number 5, we will derive that Mc equals to Fc over 2, Fc equals to x1 square root of 2, x1 square root of 10. And therefore Fc over 2 will be equal to x1 square root of 10 over 2. So in conclusion, we found out that MC equals to x1 square root of 10 over 2. Okay? Then we proved that those two right green triangles are similar to each other. But first of all, in this right green triangle, this angle equals to 90 degrees. This angle equals to theta, so this angle must be equal to 90 degrees minus theta. For the same reason, this angle must be also equal to 90 degrees minus theta. So first of all, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Okay, here, angle EDA equals to angle MEC equals to 90 degrees minus theta. In addition, we have those two angles, they are both equal to theta, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So in conclusion, we found out that all the angles of the green right small triangle ADE can go into all the angles of triangle EMC. Therefore, triangle EMC or triangle ADE is similar to triangle EMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude that AE over EC equals to DE over MC. AE equals to square root of 10, EC equals to 5, DE equals to 1, and MC equals to x1 square root of 10 over 2. We moved 2 to the numerator and x1 square root of 10 to the denominator in this side of equation number 2, and we got that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Because multiply this equation number 2, and we found out that the square root of 10 times x minus square root of 10 equals to 10. We substituted 10 by square root of 10 times square root of 10. And we got that according to equation number 2, square root of 10 times x minus square root of 10 equals to the square root of 10 times square root of 10. We divided this equation number 2 by square root of 10. And we got that according to equation number 2, here x minus here square root of 10 over square root of 10 is 1. So in this side of equation number 2, we left only with x minus square root of 10, and here square root of 10 times square root of 10 over square root of 10 is square root of 10. So in conclusion, we found out that according to equation number 2, x minus square root of 10 equals to square root of 10. We added square root of 10 to this equation number 2, and we found out that x equals to square root of 10 plus square root of 10 is 2 times square root of 10. So the answer to the question is that x, the variable that we are looking for, equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we found out in both methods the same results for x. That is actually equal to BC. Okay, thank you very much.